Okay, so let's look at an infographic from Ocean Visions on enhanced alkalinity for CO2 removal. We talked about the research news article of the same topic, but here let's look at the science a bit more. Also, we get to see alkalinity in a bit more detail here. So carbon dioxide in seawater plus alkalinity gives us carbon stored in the ocean as bicarbonate. Remember, calcium ions combine with bicarbonate to give us calcium carbonate, which has to be supersaturated at the surface so that calcium carbonate forming shells can survive. If it is undersaturated, not supersaturated, then they begin to dissolve, which is what is also ocean acidification. So CO2 plus H2O and alkaline materials will produce more bicarbonate ions. So CO2 dissolves very easily into the ocean. Alkaline solutions can be returned to the sea through outfall pipes after it's been taken in, and alkalinity is produced by produced electrochemically from seawater. So coastal infrastructure can be co-produced or co-purpose for alkalinity production and delivery, which we will see as another infographic on biochemical or what is it? Electrochemical ocean carbon dioxide removal in the next podcast. They are closely related, just the details are different. So somehow, ocean water cannot be just produced in a lab by adding salt to water. You think of ocean water as salt water, but actually alkalinity is very important because it has many salts which give it H plus. So you can see H plus ions that are necessary for this neutralizing ability. That's what alkalinity is all about. So mining alkaline materials, silicates and carbonates, and bringing them here and dumping them on the beach, spreading silicate minerals. So you can again mimic the natural processes that happen through weathering and the water that flows in through groundwater and streams and rivers and so on and so forth. And of course you have lime and lime kiln. CO2 is produced from lime production sequestered underground, which is what a lot of the lime kilns are cement production, but you can alter that process to take out CO2 because it's a point source. It's easier to do, but energy used is really high for cement production, which is also something to worry about in terms of reducing emissions. So beach spreading of silicate materials, or you take these materials on a ship and do ocean spreading of alkaline materials, and you drive more CO2 uptake as shown here. So carbon dioxide removal happening through natural processes, and alkalinity is important for that, and we are enhancing those processes here. As we said, we always have to do life cycle analysis to see how much energy and emissions are involved in doing these things, mining alkaline minerals, doing the processing to make them soluble, let's say, or to really make them into fine dust, so that when you spread it on the beach as silicate material or calcium carbonate as lime, they are easily soluble and not just sit there like a rock on geologic timescales to be weathered by natural processes. So enhanced weathering on land is also proposed, which also involves grinding up olivines and other rocks into small pieces so that the volume surface to volume ratio, surface area to volume is increased, so that weathering rates are increased. Global warming does increase weathering as well, because warm temperatures favor increased weathering rates, but those are much slower processes as well. Okay, so many ways to try and accelerate the ocean uptake or enhance ocean carbon dioxide uptake, or ocean CDR. So let's leave this here under 5 minutes, but that's okay. We'll come back and look at next the electrochemical ocean CDR, which is just a bit of enhancement on this process. All of these have co-benefits, as we say. These here it says we can co-purpose for alkalinity production and delivery. So you are doing something else, and you are taking seawater, let's say, to cool your thermal plants or whatever, or desalination maybe, and so on. But you are using the system and co-purposing it for producing alkaline solution to put back into the ocean instead of releasing polluted or warm waters. There's a lot of very warm waters being released into rivers and the oceans by various power plants and nuclear plants and so on that we worry about, but maybe there is a way to use that, repurpose them and co-purpose them for enhancing alkalinity and ocean CDR. So see you in the next topic.